So here's my system. That's some fixed thing. Here's a little spring. And there's a little car on a track here, I guess. So there's the mass. Some mass in the little car. And the motion is damped by what's called a dashpot. A dashpot is what, like the sort of thing that you see them in everyday life as door closers. They're the things up above that you never notice that prevent the door from slamming shut. If you take one apart, it looks something like this. So that's the dashpot. It's a chamber with a piston. This is a piston moving in and out, and the air, compressing the air and releasing it is what damps the motion of the thing. So this is a dashpot, it's usually called. And here's our mass in that little truck, and here's the spring. And then the equation which governs it is, let's call this x. I'm already going to change the dependent variable from y to x, but that's just for the sake of example, and because the track is horizontal, it seems more natural to call it x. There's some equilibrium position somewhere, let's say here. That's the position at which the mass wants to be if the spring is not pulling on it or pushing on it, and the dashpot is happy. I guess we better have a longer dashpot here. So this is the equilibrium position where nothing's happening. When you depart from that position, then the spring, if you go that way, the spring tries to pull the mass back. If it goes on this side, the spring tries to push the mass away. The dashpot, meanwhile, is doing its thing. And so the force on is the mx double prime. That's by Newton's law, the force comes from where? Well, there's the spring pushing and pulling on it. That force is opposed. If x gets to be beyond 0, then the spring tries to pull it back. If it gets to the left of 0, if x gets to be negative, then that spring force is pushing it this way, wants to get rid of it, get rid of the mass. So it should be minus kx, and this is from the spring. The fact that it's proportional to the amount by which x varies, so that's called Hooke's law. Never mind that. This is a law. That's a law, Newton's law. Okay, Newton. Hooke with an E, and the dashpot damping is proportional to the velocity. It's not doing anything if the mass is not moving, even if it's stretched way out of its equilibrium position. So it resists the velocity. If the thing is trying to go that way, the dashpot resists it. If it's trying to go this way, the dashpot resists that too. It's always opposed to the velocity, and so this is a dashpot damping. I don't know whose law this is. So it's the force coming from the dashpot. And when you write this out, the final result, therefore, is that it's mx double prime plus cx prime. It's important to see where the various terms are, plus kx equals 0. And now that's still not in standard form. To put it in standard form, you must divide through by the mass, and it will now read like this: plus k divided by m times x equals 0. And that's the equation governing the motion of the spring.